49. All right, so yesterday we completely factored our polynomials into complete factorizations that included irrational numbers and imaginary numbers in sum. So today we're going to kind of go the other way. And we're going to use our zeros and our y-intercept to write equations for these functions. So these are the zeros. They should have these on there, but the way this is formatted, it was more trouble than it was worth to go back and put them in. So just know it should be that way, and we can write them in as we go. All right, so I'm given the zeros, and I'm given the y-intercept. So just because I know where the zeros are and the y-intercept doesn't necessarily mean I know how much things are stretched and shrunk and things like that. So one of the things that is missing, so I want you to think if we completely factored something. So if I had, I'm just making this one up. If I had f of x equals 4 times x, and you don't have to write this down, x minus 5 times x plus 2, right? So that's a quadratic. My zeros are at 5 and at negative 2, right? This 4 that I factored out in front has no bearing on what my zeros are, right? And if I dropped it off when I factored, which is a big fat no-no, I still would have gotten the same zeros. But this does have an effect on the way the graph looks, right? And it will have an effect on where my y-intercept is. So basically, this is your a value, and we have to figure out where our a value is on these. So when we start to write them, so we'll start with an f of x equals, we don't know what a is. We're going to go figure that out, but I can go ahead and put the factors in from my zeros. So since the factors are always x minus c, this negative 2 would give me x what? Plus 2. Good. Make sure you got that right in your head. Is my next one going to be x plus 4/3? No, because what I have here, and if you need to write it off to the side, which I don't think all of you will, but maybe somebody does, but that's what that says. I would multiply both sides by 3, so 3x equals negative 4, so 3x plus 4 would equal 0. That's my factor. I have a feeling you can look at the fraction and know that. Just make sure you don't mess up the sign. So this is actually going to be 3x plus 4, and then this 2 makes this what? X minus 2. Okay, all that makes sense so far? So that at least gives me my zeros. I know something about the function, but I have this y-intercept, and that's going to help me find a. Well, this y-intercept, that means that f of 0 is equal to negative 32, because your y-intercept, when x is 0, y is negative 32. So I can substitute in what I know. F of 0 is negative 32. That's equal to a times, well, if x is 0, then this just gives me 2. And then this would just give me 4. And this would just give me negative 2. Right? Make sense? So then I clean this up. Negative 32 equals, so I know this will be negative. 2 times 2 is 4 2 times 4 is 8 times 2 is 16. So I get negative 16a. That means that a is equal to 2. So then I can write my function, f of x equals 2 times x plus 2 times 3x plus 4 times x minus 2. This is my function. What questions do you have? Anything? Easy enough? Okay. So let's do number 2. Again, these are my zeros. How many zeros do I have? 4. Okay. So I'll have f of x is equal to a, don't forget to put your a there first, times. So this would give me x plus 2 square roots of 3 and x minus 2 square roots of 3. And when you have a plus or minus, if you get the x minus c thing messed up, it doesn't really matter because you end up with both of them anyway. Times x plus 1 times x minus 1. And of course, these could be in any order. That's not really that important. Okay, so then, bless you. When f of x is negative 12, so when y is negative 12, x is 0, so that's going to be a times 2 square roots of 3 times negative 2 square roots of 3 times 1 times a negative 1. Okay, so when I multiply all that out, is it going to be positive or negative? Positive. Okay, so really the ones then are kind of, once I know it's going to be positive, I don't even need to worry about those. I just have to multiply 2 square root of 3 times 2 square root of 3. What's that? What's 2 times 2? 4. What's the square root of 3 times the square root of 3? 3. So what's 4 times 3? 12. There you go. So this is 12a. So a is equal to negative 1. Then I can write my function, f of x equals negative, and then I have x plus 2 square roots of 3 times x minus 2 square roots of 3 times x plus 1 times x minus 1. Any questions about where any of that came from? Okay. Got to know how to handle your square roots. Okay. So let's look at number 4. Here are my zeros. And I have multiplicity in these, so I can start off with f of x equals a times, this negative 3 gives me x what? Plus 3. Then I would have x minus 1. 5 halves would give me what? 2x minus 5, right? Okay, so then I have multiplicity there, and the multiplicity is on the 5 halves, so my multiplicity of 2, I put my exponent of 2 on there. Which means on the graph, what would happen there? A bounce, okay, which means it would be tangent. Which is not what this question's asking, but we still need to know that. All right, so then my y-intercept is at negative 15, so that's equal to a times 3 times negative 1 times negative 5 squared. So one of the quizzes you're going to get back today is your sketching of polynomials. And some of you, when you went to find the y-intercept, you completely ignored multiplicity, and your y-intercept was way, way off. You don't get to drop these exponents. It's not just a negative 5, it's negative 5 squared there. All right, so then I have negative 15. That's equal to, all right, so negative 5 squared is a positive 25 times negative 1 is a negative 25. Negative 25 times 3 is negative 75. Okay. So that means that a is equal to negative 15 divided by negative 75. Okay, so I know some of you can reduce that very easily, no problems. But if you don't know how many times 15 goes into 75, you don't have to start there. Start a little bit at a time instead of guessing and checking. They are clearly both divisible by 5, right? And it's also going to be positive. So 15 divided by 5 is 3. What's 75 divided by 5? So 5 goes into 7 once with 2 left over, and then that's 25, so it's 15, right? And then 3/15 will reduce to what? 1/5. So when you're dividing, you can think of it as reducing a fraction, and you can reduce in stages until it gets to something that you know. Even if it takes you a few times, it's fine. If you can go straight there, that's absolutely fine too. That's the goal, but. So f of x is equal to 1/5 times x plus 3 times x minus 1 times 2x minus 5 squared. Okay. What questions do you have? Anything? Okay. Let's do one more, just because of time, because the quiz took so long, we'll just do these together. All right, so I've got, these are my zeros. So f of x is equal to a times x plus 1 to the 3rd power, right, because I have that multiplicity of 3. And then that 5/4 gives me what? 4x minus 5. So 5 is equal to a times 1 cubed times negative 5. If you forgot the multiplicity here, you'd get lucky and get the same answer. So this is going to be 5 is equal to negative 5a. A is equal to negative 1. So f of x is equal to negative x plus 1 cubed times 4x minus 5. What questions you got? Anything? All right, so we also need to be able to do these from graphs, okay? So it says write a function in any form that would match the graph shown below. So it's like a function, not necessarily the function, because we don't know, we know a lot, but we don't know everything we would really necessarily need to know at this point based on our level of knowledge of polynomials. But we're going to start with f of x equals a. Always do that, right? Then this here is at a positive 1, so what goes in here? X minus 1. This 0 is at a positive 6, so what goes in here? X minus 6. Okay, do I have multiplicity? Yes, tell me about it. It's even. So all you really know is that it's even, right? Because it's a bounce, that comes from the even multiplicity. So we're going to go with 2 because that's the best we know right now. But remember, it doesn't have to be a 2. It's an even when it's a bounce, okay? All right, so then we're going to have to figure out A. What's the y-intercept? Negative 30. So negative 30 equals A times negative 1 squared times negative 6 squared. So negative 30 equals, so negative 1 squared is 1, negative 6 squared is 36. So A is equal to negative 30 divided by 36. When I reduce that, it will be negative. Negative what? Five over 6. So f of x is equal to negative 5/6 times x minus 1 squared times x minus 6 squared. Okay. What questions you got? Okay. So on this next one, I start just like the rest of them. F of x equals a. My first 0 is at negative 2, so this is x plus 2. And then my other 0 is at 5, so that's at x minus 5. Do I have any multiplicity at x plus 2? Yes. So that would be squared, right? Anything at x minus 5? No, it's just a pass-through, so that's it. All right, so you go ahead and find A and write your equation. While you're finishing that up, I'm going to pass these out. Be careful being able to read your own handwriting. And I'm not just saying that if you have bad handwriting, because last period, somebody that has pretty decent handwriting, probably better than mine, at this step right here, they had negative 180. And I was like, where did you get negative 180? And he was like, I don't know. Well, his A kind of looked like a 9. And so he used it as a 9, and that's where he got that from. So, you know, sometimes you kind of just do weird things and you confuse yourself. So be careful. Ask me if you don't understand where something came from.